Welcome back, everybody. We are now looking at accelerated motion, and this is a half sheet of paper, and it is absolutely full. To understand this really takes some attention, so please don't have your mind anywhere else. Try to follow me and to try to understand what I'm doing, okay? I really like this a lot. It is beautiful when objects accelerate because what you're going to see is that they'll accelerate it exactly the same way each time. If you do something the same way, it'll accelerate the same way. The world is so predictable that you can have math based upon it, and that's what we're going to see. You've got two formula that you're going to have to learn, and they're really easy. First of all, I want you to know that A is going to equal acceleration. So A, acceleration. We looked at G the other day when we did weight. If you remember, weight was equal to mg, and m was the mass of an object, and g is gravity, the pull of gravity on that object, and it was 9.8 meters per second. If you simply drop something, it's going to accelerate at 9.8 meters per second. If you have a ramp, what'll do, some of it's gravity. This aspect of its gravity, but since it's being forced to go a much longer distance, it's not falling simply from here to here, but it's going a much longer distance, it's going to take longer to get there. And so the gravity, that 9.8 number that we saw, or we just used 10, will slow down. And so right now, this example that they're doing, number 3, has it going at 2 meters per second. So if you have something at this angle, it will slowly roll down, and it's getting faster and faster. You know that by any object in gravity field is going to get faster. It's going to go a certain distance in 1 second. It's going to go a longer distance in the second, longer still, longer still, longer still. Okay, so it is going to speed up, but it's going to speed up very, you can make a guess. You could actually guess this. It's really, really simple. So first of all, let's look at how far that it's going to, let's look at a speed first, okay? It said that the acceleration was 2 meters per second squared, okay? So that's actually, so acceleration here, this is acceleration of this particular one. If it were steeper, it would be more towards g, so it would be higher than 2. If it were straight up and down, it would be 9.8. So it's any tilt that you can have would be somewhere between 0 and 10, okay, because it would be more and more of a percentage of pure gravity without any ramp to fall down. The ramp would be shorter and shorter and shorter as you got steeper. All right, so if it's at 2 meters per second, so 2 meters per second is a speed, and then every second it's getting 2 meters per second faster, okay? Every second, it's getting 2 meters per second faster. So so let's look first of all at the velocity. Velocity is going to be, you're going to see that the velocity is going to equal AT. So here's the first one that you need to know. I'll put a box around that. Velocity at any time is going to be equal to the acceleration, which in this case is 2, times the time. All right? These are 1 second apart. Each one of these is 1 second, it says. So that means at 1 second times 2, the velocity is 2, and they gave you that. Okay. How about at 2 seconds? 2 seconds times 2, the velocity will be 4 meters per second. Okay. What about at 3? 3 times 2 is going to be 6 meters per second. Do you see? So it's getting faster. It gets faster as it rolls down. The farther it gets towards the center of the earth, the more gravity pulls on it, the more it speeds up. So here we're going to have, this is 1, 2, 3, 4 seconds. So 4 times 2 is 8 meters per second. And then this is 10 meters per second. So there's your first one. Okay. Let's look at the next one. Okay, so what do we have here? We have that in the first second, it travels 1 meter. So here's another, this is now another formula. I'll put a box around that. So here, V equals AT was up here. And then the second one, d equals 1/2 at squared. This is the distance formula. So this was the speed formula. This is the distance formula. D equals 1/2 at squared. So a here is 2 because it's very consistent here in this on this ramp. It's one particular steepness. So in the first second, how far does it fall? All right, so we've got 1, because 1 times 1 is 1. 1 second squared is 1. Times the acceleration is 2, so this is 1 times 2, so this is 2. 1/2 of 2 is 1. So in the first second, it travels 1 meter. Okay, since the acceleration was in meters per second, in 1 second, it travels 1 meter. All right, so this was marked already. How far is it going to go in the first 2 seconds? So this one already, we can tell it's 4 because I gave it to you. So let's see. In the first 2 seconds, 2 times 2 is 4, times 2, which is our acceleration, is 8. 1/2 of 8 is 4. Okay, so in the first second, it goes 1 meter. In the first 2 seconds, it goes 4. So what did it travel in the second second? 3 meters. Okay, now let's see if that makes sense. Every second, it's getting 2 meters per second faster. Okay, so in 1 second, it travels 1 meter. In the next second, it's going to travel 2 meters per second faster than the first second. So 1, which it was before, plus 2 meters per second is going to make it travel 3 meters. In the first 2 seconds, then, the distance formula tells us that it's 2 times 2 is 4, times 2 is 8. Half of that is 4. So then first 2 seconds is 4. How about 3 seconds? In the first 3 seconds, 1, 2, 3, how long is this number? Okay, well, so this is 3 times 3 is 9, times 2 is 18, divided by 2 is 9. Okay, so this is 9 meters. It travels 9 meters in the first 3 seconds. Well, how much is left over? We've already gone 4. That means it's going 5 meters. Do you see? Do you see a pattern here? Can we fill out the rest of the pattern? In every second, if it's going 2 meters per second faster, it's going to travel 2 meters farther in that second. So we traveled 1 meter, and then we went 3, then we went 5. What's your guess here? This would be 7. It's going to go 7 meters. What about here? It'll go 9 meters. Okay, so this is simply 2 meters more in the next second because it's getting faster by 2 meters per second every second. So in the next second, it's going to get 2 faster, and the next 2 faster. And since it's faster, it'll travel that far. It'll travel 5 meters in that second. It'll travel 7 meters in the next second. It'll travel 9 meters in the next second. It's progressively getting faster. Okay? So what about, this is the first, second, third, fourth. What about the fourth second? What's the pattern here? We've got a 4 and then a 9. Is that enough for you to see a pattern? Okay. We've got 1 times 1 is 1. Okay. In the first second, it went 1 meter. In the first 2 seconds, it went 4. Okay. 2 times 2 is 4. What's this? 3 times 3 is 9. So here, this is getting longer by exponents because the distance, this is the distance formula. It's going the first 1 second and then 2 seconds and 3 seconds. Do you see? It's based on the square. So 2 times 2 is 4. Times 2 is 8 divided by 2 is 4. 3 times 3 is 9. Times 2 divided by 2. See, in this case, these two will cancel out. This is going to be half of what we just happen to have as our A. So 1/2 of A is going to be 1. So this was always going to be 1. So your distance is always going to go up in this particular example by squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9. What goes here? This is 16. It's going to go 16 meters in the first 4 seconds, and then it's going to go 25 meters in 5, because 5 squared is 25, 4 squared is 16, 3 squared is 9. Okay, so let's answer a couple questions. Do you see the total distance from the starting point increases as the square of time? As seconds multiply by themselves, okay, your square seconds, suddenly now your distance is going up by a square. Okay, so knowing that, you've got 4 and then 9, 16, 25. If the incline were to continue, this was Galileo, he's great. Predict the ball's distance from the starting point for the next 3 seconds. Okay, so it's 25, that's 5 squared. What's the next one? Okay, this was 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. The next is going to be 6 squared. What is 6 sixes? 36. It's going to go 36 meters. What's 7 sevens? It'll now go 49 meters. What's 8 eighths? It'll go 64 meters. Okay, and last question. Note the increase of distance between the ball positions with time. Okay, so you have 1 and then 3 and then 5 and then 7 and then 9. Do you see an odd integer pattern? Galileo also came up with this for the increase. If the incline were to continue, predict the successive distances between the ball positions for the next 3 seconds. Well, 1, 3, 5, 7, 9. What's the next one? It's 11 meters. What's the next one? So it's always going to be 2 more. So it'll be 13 meters and then 15 meters. Okay. This is dazzling. I love this. It makes it's beautiful, beautiful, beautiful. And I don't know that you could understand this in one time through. I hope you watch this again. Make sense of it. This is gorgeous. Praise God for this. All right. See you later.